We will now talk about while loop. While loop is an iterative statement that will execute some block of code over and over as long as some condition is returning true. I will show you here an example. I will create one function that is using while loop. I will then test this function by using this select statement, and we will see that for this argument here, this will be our result. So how we got this final result? Well, our result will have its initial value, which is empty string. And in each iteration, because this is one iterative statement, we will get one part of our final result. I will jump to this web page here, we can see that better. This is our initial value of result, and in each iteration we will add underscore and we will add one letter from our argument. So in the first iteration we will add underscore ns, so this will be our interim result. And in the next iteration we will start with the previous result, and then again we will add underscore and we will add one letter from our argument to get this. And we will continue with this until we get our final result. Now the problem is that this final result has underscore at the start, so we will use string function to remove that underscore and to get final result. So how we can take each time a different letter from our argument? Well, for that we can use this variable here. So first we will get the first letter, then the second, then the third, and so on, because in each iteration the value of this variable will change. I will now go back, and we can see that this variable I will also have its initial value, and that in each iteration this initial value will be increased by 1. So that means that first will be 1, then 2, 3, 4, 5, 6, and so on. So we will use the first letter, the second letter, the third letter, until we reach to the fifth letter. But how we know when to stop? Well, this variable I is also part of our condition. And this condition in the start will be whether 1 is smaller or equal to 5, because we have 5 letters in our argument, and then it will be whether it is 2 smaller or equal to 5, and then 3, and then 4, and then 5, and then 6. When we reach the 6th, this condition will return false, and in that case we will know that the previous value of our res variable is the final value that we will use here as a final result. I will now clean my screen. I will now give you another example here. I will create another function, and then I will again jump to this web page, and here I will tell you that we are looking for some integer for which 2 on that integer is greater or equal to the value of the argument of this function. For example, for the value 7, we know that the next number that can be calculated in this way is 2 on 3, that is 8, so the final result will be 3. Let's go back to see our function, and then we will execute this function to see if our result will be 3. It is. And how is this function working? Well, in this case, we will start with the initial value of this variable, and this variable is part of the condition. So the first condition will be 2 on 1, and this will be 2. So is it 2 smaller than 7? It is, so this is true. Then we will increase this variable x. So we will now have 2 on 2, that is 4. Is it 4 smaller than 7? It is. So then we will increase this to 3. So it is 8 smaller than 7. It is not. So we know that the last result was 3, and that will be our final result. So what is here important is that this condition is changing each time, and that this final result is changing each time. And they are changing because we are changing each time the variable that they are based on. So they are depending on this x variable, and this variable is changing each time. And at the end, when it is changed so much that this condition is no more returning true but is returning false, then we will know that the previous value of this variable is actually the final result. I will now clean my screen. I will give you one more example of the while loop, and this is an example where we are calculating factorial of some number. I will again test this function. So I will test it for argument that is 4, and we will get 24. That is 4 times 3 times 2 is equal to 24. Again, we have our initial value for our variable. We have a condition that is true in the first iteration, and we are always diminishing the value of this argument. So first it will be 4, then we will reduce by 1, it will be 3, 2, and 1. And when it reaches 1, then this condition here will be false. So we will know that the last value of our result is actually the final value. So that is how we got this value 24. I will now clear my screen. When we use while loop, we can make a mistake. And that mistake is to create a condition that will never return false. This condition here will always be true, but we can still create such function. And if we run that function in our select statement, this function will never return a result. It will just go on and on because there is no condition that will return false. So we have to stop this function violently, and we can do that inside of this M client by typing on Ctrl+C. So if I type Ctrl+C, I will stop execution of this function. So depending on the client that we are using, we always will have some button or some command that we can use to stop execution, and we can do that if we notice that our function is taking too much time. Next, I will show you that we can nest while statements. So I will give you this example here. Here we have a function that has outer while statement. So this is outer while statement, and this is inner while statement. And we can create such function. And if we now try to read from this function, we will get this result. So these first figures are created by external loop, and this second figure is created by internal loop. We can see that better if we jump to this web page. Here we can see our external loop. We have internal loop, and this external loop will create these values 1 and 2, and for each of those values we will get 1 and 2 that are created by this internal loop. I will now go back and I will clean my screen. We will now talk about if statement. If statement is really simple. Here is one example. If statement will first test some condition. If this condition is true, then it will return the result after then keyword. And if this condition is false, then it will return this result after else keyword. And at the end, we will end this if statement. Now notice that we are not returning a value, we are returning a statement. So in this case, our function will return 1, and in this case, our function will return 2. I will create this function, and then we can test it. And because 1 is not equal to 2, we should get the result 2, because that is the result that we will get if this condition is false. It is also possible to test several conditions inside of one if statement. So I will give you this other example. In this case, we are going to use substatement else if. So we can add some more conditions. So this condition here will be false. So we will not return this. This will also be false. So we will not return this. But this here condition will be true. So we will return this. I will create this function, and then we can test our result. Our result should be number 3. And it is. I will now clean my screen. Next, we will see two examples where we are combining while loop and if statement. This is the first example, and the purpose of this example is to show you what we should do if we want to break our loop. Inside of Monet, we don't have break keyword. So instead of that, we have to use flag variable. So what is flag variable? Flag variable is a variable which will get some initial value, and we will test for that initial value. And while this initial value isn't changed, our while loop will work. But if we want to break our loop, then we have to change the value of the flag variable. For example, in this case, when this condition is met, we want to break from the loop, so we will just change the value of this flag variable, and that will make this condition false. so we will break from this loop. I will create this function, and then we can see the result of this function, and the result will be number 5. So why 5? Because if I is equal to 5, then we will break from our loop. And I is the result of this function, so the result will be 5. And similar to this, we have this other example. This other example will show us what to do if we want to skip some iterations. In procedural languages, we have continue keyword. So if we just want to skip some iteration, we would use continue. But we don't have continue inside of Monet. So in this case, we will wrap our calculation inside of the if statement. And this if statement will decide whether this calculation will be done inside of this iteration or not. For example, here we want to add all of the numbers from 1 to 10, but we want to skip all of the numbers that are even. So we will only add odd numbers, and for that we can use this if statement, which will tell us do summation only for odd numbers. I will create this function, and then we can test this function, and we will see that the sum of the numbers from 1 to 10, but only for odd numbers, is 25. I will now clear my screen. I will now show you something interesting. In Monet, we can create several functions that are using the same name. So I will create 3 functions with the same name. This first function will not have any arguments. This second function will have only one argument, and because of that argument, these 2 functions will be considered as 2 different functions, and I will create one more function that will use 2 arguments, and this will be, because of that, considered as a third function. So although they have same names, they have different arguments, and this is called overloading. So we have functions with the same name but different arguments. We can now try our functions. So I will first call this function that doesn't have argument, and it will return 1. This second function will return the value of an argument, so it will return 5 in this example. And this third function will calculate how much is first argument plus second argument, so it will return 25. If we now try to delete this function by using only its name, so I will use drop function, I will get a message that we have several functions with that name. So we have to provide the full signature. The full signature means that we have to tell to Monet what arguments are used by that function. So I will use this second statement. I will say that this function is using only one argument, and this argument is of integer data type. I will run this, and this is how we will delete that function that has only one argument. So if we now try to read from that function, we will get an error because this function no more do exist. But if we try to use those other functions, for example, if we use this function that doesn't have arguments, this function will work correctly because this function was not deleted. I will now clear my screen. At the end, we will talk about system tables. If we want to find out about some function, then we should read from this system table sys.functions. So I will search here for the function with this name. I will run this, and this is the data about my function. We can see its ID, we can see its name, we can see definition of our function. Inside of this system column, we can see that this is not built-in function. So if we want to find all of the functions that are user-defined functions, then we just have to apply filter that column system is equal to false. So these are all of the functions that are created by us. Previously, we saw that this is ID of our function, and we can use that ID to filter one other system table, and that system table is sys.args. So we will run this statement, and here we can see arguments of our function. But our function has only one argument, and this is that argument, and this is actually the result of a function. So each function here has at least one line inside of this table, and that line is the result of a function, and for each argument it will have another line inside of this table.